Hi, and welcome to question 6 of the 2024 paper 1 of the Leaving Cert Ordinary Level Maths. So question 6 is kind of around functions. Let's read through. The graph of a function k of x is shown on the coordinate diagram below for 0 is less than or equal to x is less than or equal to 5, and x is an element of R, which just means that it's a real number, so it can be any number. Now, the domain here between 0 and 5 just represents on the x-axis between 0 and 5. This is your function k of x, okay? And this is your y-axis, which you could call the k of x axis because k of x means y, okay? So how does y change as x changes? So as x gets bigger, we can see that y is decreasing. That's what's happening with this graph. It's not linear. It's not decreasing in a constant fashion. So it's some slightly more complicated version of a model. Now, part A says use the graph to answer parts A1 and A2. Now, A1 says estimate the value of k of x. So estimate the value of y when x is equal to 2.5. Show your work on the graph. So with a ruler, you'll bring a line up as far as the graph and then bring a line across, which is getting me in and around 6. Now it's going to say 6 because that's closest, be within the tolerance. But it's technically, based on my reading of it, slightly below 6. So if you said 5.9, totally good. Might be even a better answer. Now part 2 says estimate the range of values of x for which y is less than or equal to 7. So the line y is equal to 7 is this line here. What are the values of x for when the graph is less than that line? So from here, okay, which is somewhere around here, to here, all the way at the end. So that gives me a range. I'm going to estimate that as like 1.8 as far as 5. Okay. Or you could say 1.8 is less than or equal to x, which is less than or equal to 5. Just if you want to say, or you just 1.8 as far as 5, or indicated on the graph. So in the notes, I've done out different color pens, all that kind of stuff. Not necessarily necessary in the scheme of things, as long as it's indicated on the graph, and show your answer in the space provided. So that's part A1 and 2. So part B1 says Liam uses the trapezoidal rule, and I put that in here from the maths tables, to estimate, and it's important to remember the trapezoidal rule and Simpson's rule are estimates of the area. So to estimate the area under the graph of k of x between 0 and 5. Okay, so in a sense, in the last image, we're trying to estimate the area of this entire, just clear off the ink, this entire shape here. Now, in essence, what the trapezoidal rule does is it breaks it down, that shape, into little intervals. Okay, at least that's what I'm going to do, be using the trapezoidal rule. And we're going to estimate the area of each individual thing, and then trapezoidal rule adds them all together, okay, at the end. Now, calculus or integration is a slightly better version of that, but it's not on the ordinary level maths course. But we do differentiation, and integration is in essence the reverse of differentiation, okay? So a similar process, just different. So the trapezoidal rule, we've written it out here. So the area is equal to h over 2 by, now I'm going to kind of use a different version. First plus last plus twice the sum of everything else. Now it's crude, but it does the job. That's all this is saying. Y1 is first, yn is last, and 2 times everything else added together, in essence. Now, the h value is the difference in here. That's the h value, which is a difference of 1. So h is equal to 1. Now our first is equal to 12. Our last is equal to 2.8. And everything else in between, we're just adding them together. I'm going to use the answer I have in the notes because it's tidier. So that's our formula. Okay, I've written out all the points here. Y1 is the first, Yn is the last, and all the different like heights we have throughout that shape. Then I put them into the formula. So the h value is 1, first plus last plus 2 times everything else, 9, 6.8, 5.1, 3.8, and that's it. I put that through the calculator and I got 32.1 units. I probably should have finished the question. Using the values of k of x in the table above, show that the trapezoidal rule will give an estimate of 32.1 units squared for this area. So that's what I got. That's what they're asked me to get. I'm happy out. And this is just an example of the trapezoidal rule.